Hello, everybody. I'm Sarah Shewey. I am the founder and CEO of Happily. We are the largest, most diverse network of independent experience specialists. We produce carbon zero experiences and live broadcasts for some of the world's greatest, I think, companies and organizations who are making an impact on our planet and in our society. And every once in a while, I just pop into my socials to say hello to everyone and introduce you to a friend and a colleague and just have a little bit of a live chat. Today, I'm really excited because we are connecting today with Barent Roth. Barent Roth, he's someone that I've known in the early days of my journey in sustainability. I met him back in, I'd say 2000. Dude, I'm dating myself right now, 4, 5, 6 in Los Angeles. Barent's currently in New York today, and he's relocated there, and he's the co-founder of Circular Economy Manufacturing, and he's actually on location, which is really fun, and he's going to tell us a little bit about that. Hi,
Hey, Sarah, how are you? Great
Barent.
to join
Good.
you. Great to catch up in this format.
I know, it's amazing. I mean, wait, will you come to the screen a little bit closer so we can see your,
Sure,
you see your
sure.
face?
Yeah,
Yeah.
no,
Oh
sure.
my gosh, it's good to see you. What is
Good
that
to see you.
cool structure behind you?
This is our MicroFactory. It's a solar-powered shipping container that takes single-use plastic and turns it into durable goods. So we're here on Governor's Island and happy to give you a tour of our facility.
Wait, this is so cool. How did you get in? How long has this project been going on? How did you get into this?
Well, it's great that we're on Governor's Island because the project actually gets its roots here. You know, for me from way back when in sustainability, when I was executive director at Sustainable Works and running LA Green Drinks, but I was also always designing sustainably. And we had a design firm called Anthropocene.Design that we still run that entered a competition to turn New York City's trash into products. And the
Mm.
founder of that competition was inspired when he came to Governor's Island and saw these recycled plastic chairs that are on the island. And he turned it over and he looked at it and said, wow, this is my uncle's company in Indiana called Pollywood that makes this chair, and knew that that plastic came from metropolitan areas like New York, Chicago, LA, big cities all over the US, sent to Asia, China at that time, then sent back to Indiana to be manufactured into planks and then eventually a chair. And he thought, you know, he was living in New York at the time. He saw the piles of trash on the sidewalk. He said, there's got to be a better way. So he created a competition called the New York City Curb-to-Market Challenge. And we, long story short, we ended up being one of the co-winners of that competition. And we used that to create this. So shortly after we won the competition, Governor's Island announced that they were going to be a research focus and research hub for climate change initiatives. And they started hosting the Climate Change Museum exhibitions in one of the buildings here. And when we learned that, we thought, this sounds like a great place for our solar-powered MicroFactory, right? Our name of our company, Circular Economy Manufacturing. We thought this seems like a good fit. When we met with Governor's Island, they agreed. They said, wow, this is terrific. We love the Climate Change Museum. They're here educating people about the problem. We love what you guys are doing because you're presenting a solution. So that was pre-pandemic. And as you're probably reading about all the supply chain issues now, we've been experiencing those for the last 2 years. And again, long story short, it took us a while to get here, but the MicroFactory arrived last month and we're in the midst of installing the full operation. We have most of our 40% of our panels up, almost half, and we look to finish it out. But this is enough for us to start testing and making products here on the island. So we're super excited about that and love to share it with you today.
That's cool. And I think I saw a video about this. we brought it up. Chris, if you can share the clip of the Kickstarter
Awesome.
project that just gives a little bit of an overview. Barent, what you're doing is so cool.
Exactly.
I want everybody to really
Sure.
understand that, and maybe after that you could take us around a little bit more.
Yeah. That'd be great.
Okay, cool.
I
Yeah,
think
like
you'll get a
let's
great
travel around.
summary, and then we'll come back after you show that clip. That'd be awesome.
Amazing.
Circular economy manufacturing is changing the way the world makes things, starting with BioCyclr, the first sustainably made food scrap collection bin. Using your single-use plastic, we are rotationally molding long-lasting products in our solar-powered shipping containers. Introducing the MicroFactory. We put recycled plastic in a mold, heat it up, and rotate it. With the success of the globe, we're ready to make food scrap collection bins, an essential for sustainable living.
My name is Barent Roth, and I've devoted my entire career to designing, educating, advocating, and currently manufacturing for what is now known as the circular economy.
Our first MicroFactory is on Governor's Island, a climate change hub just south of Manhattan.
We're in the midst of our installation, and yet with 40% of our panels in place, we're able to collect enough of the sun's energy to store it in a battery bank, shred plastic, melt it, and mold it in our operational rotational molder. That means that we can turn single-use plastic into durable products.
Our bin is long and narrow for odor-free storage in a freezer door, while also preventing spills when sliding food scraps off your cutting board. It's easy to wash, dishwasher safe, and fits compostable bags. Each product is unique in color and made by using recycled plastic and renewable solar energy.
My name's Chris Graff. I've spent my career in manufacturing. Usually plastics collected in the US, shipped around the world for processing, and then shipped back to the US to be made into products, all powered by fossil fuels. I partnered with Barent and we created a manufacturing operation that tightens the loop. This is how we do it.
Solar panels collect energy that powers the entire shipping container, and batteries store energy for when the sun isn't shining. Recycled plastic is run through a shredder to create plastic flakes. The flakes are poured into our product molds, and then the rotational molding machine is activated. Electric heaters melt the flakes, forming a thin layer of plastic in the mold. After a few minutes, the heat is removed, the plastic hardens, and we have our product.
We're bringing urban manufacturing back, but this time for a circular economy. Our process supports the technical cycle, using solar-powered microfactories to recycle single-use plastic into durable goods, while our first product supports the biological cycle, regenerating natural systems through composting. When you support our campaign, the reward is so much more than the tangible object. You're helping us bring that sustainable, resilient future into the present. Join us today.
Wow, that is super cool. I love that your
Thanks.
first product is this awesome compost bin too. Like it just really
Yeah, we're
drives it
excited.
all the way. Is
We're
that it?
excited about it.
What do you
Yeah.
have there?
Yeah, so this is it. This gives you size and scale of what it looks like. We're live here on the island, so of course there's lots of activity happening. Anyway, so you get a sense of what it's like, how it fits in your freezer door. This is a 3D printed one out of biodegradable plastic, but then obviously ours would be made in our machine using recycled plastic. So this is what we had for the first year on the island, as we tried to explain how cool our process would be as best we could. But we'll start here, and then I'll walk you over into
Yeah, I was like, take us to that weird like globe wood thing.
Yeah. So this kind of like summarizes the whole project, right? We take single-use plastic, we shred it up into little shreds that look like this, right? So these laundry detergent bottles are an example. They're HDPE, right? And we take plastic like that, shred it up, put it into a mold. Now this one is clear, so you can see it, what happens on the inside, but the actual molds are metal. We use aluminum because it has great thermal conductivity. And when we take the shredded flakes and put them in the mold, we then start spinning the mold. And so there's two axes that are rotating at once. There's an outer frame and an inner frame. And then once it's spinning, we also start adding heat. And so it spins at a pretty slow rate. So it's not centrifugal force, it's gravitational force. And the gravity pulls all the plastic to the bottom where it continually gets heated. And so what it starts to do is melt onto the surface of the mold and cover the entire mold entirely, so that once we ensure that it's melted thoroughly, we remove the heat, let it spin a little bit more, waiting for it to cool, and then open up the mold, and then we have different products. So these are all products that we've made on with the mold that I'm about to show you. So it's the same mold. These are all just different ingredients inside that mold. So these are all tests of shredding up a laundry detergent bottle, putting it in the mold, and then getting our finished product. So our resultant product is a plastic hollow object that we can create multiple forms with. So our first form is a souvenir globe for Governor's Island that they asked us to make. And what we found really interesting is that when you smell it, I know you guys can't really smell it on TV.
What does it smell like?
It smells like the laundry detergent bottles. We were blown
that's
away.
refreshing.
It's like, oh my God. It's like, it's been shredded, melted, molded, and then popped out, and it still smells like laundry detergent. We're like, it's a little scary, but we know that these are all safe plastics.
It's like a cleaner version of the Tide Pod.
Yes, exactly. As soon as we smelled this, we're like, oh my gosh, we have to make a laundry basket so that, you're putting your clothes into a basket that smells like clean laundry. Anyway, so we are going to make a bunch of other things. One of them, these are scale models, right? This is not just tiny furniture, but these are scale models. These are 1/6 scale models of a kindergartner's chair that will mold like this. It'll come out of the mold in this shape, and then we'll cut it in half, and then it will stack and form two chairs.
Ooh.
So we'll mold things like that. And then we also, for Governor's Island, we made a traffic cone that'll work in much the same way. And since we're here on Governor's Island, we used the form from the World Trade Center tower to inspire the shape of this traffic cone, because we can. We thought, yeah, let's go ahead and do that and have some fun with it. So we look forward to making some of these products. We've designed a whole bunch of other things as well that I look forward to making, but right now we're starting with the BioCyclr, our food scrap collection bin, on Kickstarter. So
how does it?
we'd love to. Go ahead. What's your question?
Well, I was going to ask, how does it scale? Because I just keep hearing Zoolander, what is this? A traffic cone for ants?
No, this is again 1/6 scale, and I think I can best answer your question if we go over to the MicroFactory. So Celeste, who's behind the camera, is going to walk over.
Thanks,
and I'm going to show you
for this wonderful Mr. Rogers moment. This is awesome.
Yeah. So we're going to walk over, and you can kind of see where everything is. So this is what we call our control room. And maybe do one quick shot up at the solar panels before we get set up there. So as I mentioned, we have 40% of the panels are in place. We have another row on the left here, and then 2 more rows that'll go in on the right that we will eventually install. And we have 3 rows of 8 batteries. So a total of 24 batteries that are inside this control panel currently. So we use the batteries to store the sun's energy. We then power our shredder, our motors, and most importantly, the heater for our rotational mold. So we anticipate that by looking at the data from the New York City's area and how many cloudy days and how much sun we get, we wanted enough juice in these batteries to hopefully power us through 3 consecutive overcast days in a row where we could still be operational. After that, we might start, cleaning up or something like that. So hope it doesn't come to that, but yeah, that's the plan. That's the plan. So Well, I'm going to open this up and we'll walk in and show you the mold, and then I will turn it on. So
Wow, awesome.
I'm going to go inside, open up the door. We'll get a close-up shot inside the mold so you can kind of see what's going on. Then I'm going to clamp it shut and lock it down. So
Okay,
hold on one moment.
Okay. I'm just really curious about like all of this. I've never heard of a fully solar powered factory before, but maybe that's just my, lack of expertise in this space. I'm
No,
like,
that's
look,
yeah, we're the first to do it. So here's
oh,
kind
you're
of
the first to make a solar powered factory. That's awesome.
yeah, I'm gonna shut everything off here real quick. So there are other manufacturing facilities that use solar for sure. We're the first to do it in this manner, where it's a portable shipping container that's entirely solar powered. Where the solar can be stored inside, and we can travel. There are
I love the
a lot of
mini
other
factory. It's so cool. So
yeah,
at this scale, like what's the sort of like largest diameter, or what are the largest dimensions that you can make?
so anything. Celeste is gonna walk over here.
Oh, it's like a 6 feet or something?
Yeah. If you look at this inner frame here,
4?
we've
Yep.
got over 4 feet and over 4 feet. So within this inner frame, anything that fits in there, we can make. So right now we've got this little test mold in here, which is, obviously pretty small, but we wanted to test it, prove the idea works, and then, we could put, a traffic cone could fit right here, and we could do 2 of them at a time, right? So there would be 2 cones, 2 cones, 2 cones. So we anticipate at least 6 traffic cones at one time. So we could fill it all up and then turn it on. So the plastic goes in here, the shredded bits. And I don't know if you want to try and get close and do a little quick peek into
Yeah, get
that.
in there.
So we got a little handle on here. This was put together by Mark Ventura. He's a brilliant rocket scientist in your neck of the woods. He's in Southern California, down in Huntington Beach, worked on the space shuttle for over 10 years. He and Andrew Street collaborated on this for us. And then our David Gibbs helped us with the solar installation. So we've got a great team, and wouldn't have been possible without everybody, including Celeste and Bella and Maite. So anyway, take a peek in here, Celeste, if you can. And we're going to try and get closer, or you can just lift the whole tripod in. Yeah, you don't have to come in too far, I think. And then tell me if you're aimed at the mold, and I'll go ahead and open it up. Okay.
What is this?
So this is the mold where
Okay.
we put the plastic, and you can see we got it filled up. And this is where we would mold the souvenir globes. So we would put the plastic in here, and
Oh, wow. Oh, wait. Hey, Barent, you had like a blip, so you got to unmute yourself over there. Cool. We got you now.
is it unmuted now? Okay, great.
Yeah.
Thanks, Celeste. So I'm not sure where you lost me, but there's the what it looks like. We've got a mix of powder and flake in here. So when we mold this one, eventually it will be a solid watertight
What's
part.
the purpose of its little antenna?
Oh, that's a handle.
It's just a handle. It's just like,
that's a quick and dirty handle. It was like,
okay.
we kept on pulling this thing off, and it was like, Mark's like, you know what, I'm going to put a handle on there. I'm like, great, put a handle on there. So yeah, that's just a little handle.
Okay.
Yeah. All right. So now I'll go somewhere safe, Celeste, with the camera. And
Yeah.
there's multiple safety features built into this. So if this door is up, the machine won't work. If this door is open, the machine won't work. So I'm going to shut the door, and then I'm going to fire up the machine, and you'll see what it looks like when it's rotating around here.
All right. Be safe.
All right. So I'm going to just walk over here. It is pretty big. You don't want to be, it'd be a bad day if you were in here when this turned on. So
Yeah.
we're going to be super safe. and make sure everything's out of the way.
Wow, we got like really action packed, y'all. This is like maybe the best like happily live we've had yet.
All right, here we go. I'm going to be shutting now. So the garage door is down and locked, so that's one safety. Now the middle door, which we made, the middle door is actually recycled from the opening on the garage door. So now I'm going to turn on the machine. It's going to
Can we
beep at
hear
me.
it? I'm so curious what
Oh,
it
yeah.
sounds like now.
So that was the
Let's make some
emergency
cool whoosh
saying
whoosh signs.
the machine is on, it's powered up, everything's ready. I'm going to do one more visual inspection, make sure everything's safe. Yep, everything's out of there, no tools. All right, now I'm going to turn on the outer frame, now the inner frame. And so this is what it will look like when we're making products. So both axes are turning around. The machine is operating, and this is the full-size, real-life version of that wooden model.
Now pat your head and rub your belly. Sorry, I had to do it. That's amazing.
Yeah, it's kind of fun. So
How
we've
long
got
does it
some
take
signs.
to, how long will it take until it completes that
It's a great
process?
question, and that's what we're working on, optimizing each and every product, each and every cycle. With the globe, it'll be less than 30 minutes. So what we do to get there is we keep making lighter and lighter globes until they're too light, right? So we know we reached failure when we can hold the globe up in our hands and just smash it like that. It's like, okay, that's enough. That's all the plastic. That's the least amount of plastic we can put in. Or actually, let's back it up because we just crushed that in our hands. So yeah, it's kind of fun experimenting to failure, which is all part of the process, right? You have to keep on finding where's that failure point so you can step back and then know that you've kind of found the optimum efficiency for making the shortest possible cycle time.
What's the most recent failure or like insight that you've had?
Well, let's see. When we first started, there's a lot. We're doing this for the first time. One of the cool things that was kind of fun is when we were first making the globes, we weren't getting a sphere. We were getting like this Pac-Man shape. Maybe see if you can find one of the Pac-Man shapes I don't know if we have them. They're going on exhibition actually for an art exhibition right now. So I don't know if Celeste will be able to find one. But what was interesting is when we were spinning it around, initially, it looked like everything was rotating fine. And then we would open it up out of the mold and it wouldn't be a sphere. It would be Pac-Man. And we're like, what? And then we studied the mold and it wasn't rotating all the way down on every side of that cube. If you think of the mold, right, as a six-sided cube, not all six sides were facing down. And if they weren't facing down, gravity wasn't going to pull the plastic there. And so we weren't getting a complete sphere. So, part of the learning process of jumping in and trying to figure all this stuff out really quickly was let's add a second motor, add another variable frequency drive, and we were able to get the shape evenly distributed throughout. So that was kind of
That's a fun problem. Yeah.
Yeah, it has been fun like that, and that's why I say it's been really great working with Mark as he troubleshoots all these different things across the country, which now, as we're proving, is all possible.
That's amazing. And like, so are you planning, or is the plan or the big vision to scale this microfactory in lots of microfactories, or to like a larger, like giant factory that's just, I'm just kind of curious about how.
Both.
Okay.
There's some advantages to having it be small and portable and deployable. So we'd love to create this for situations that desperately need it. So Puerto Rico, Haiti, other parts of the world that don't have the energy infrastructure that they need. We can use this off-grid facility and be up and running and be recycling single-use plastic into durable goods that are most beneficial for them, whether that's life preservers or chairs or flotation devices, or whatever it might be in their area. We could deploy these portable, decentralized, energy producing microfactories and be making unique, durable products right then and there. But the other side of it is, once we show that you can do it like this, then it's certainly possible to just get a big warehouse, solar over the top, have multiple rotational molders, all powered by electrical heaters, and really change the way the world is making things, right? So it's renewable energy and keeping the plastic that we've gotten out of the ground in a technical cycle and going back into durable products.
Are you making the molds locally as well? Or I'm just curious about sort of the problem of like the transport, and all of the different like legs going ping-ponging back from different continents.
Yes, exactly. We could. It could, there's mold making capability around the world. So we wouldn't need to be shipping from one central location. The idea is that the concept is decentralization, right? It's decentralized energy, it's decentralized manufacturing. And so the molds could come from wherever that manufacturing microfactory is set up and takes root. So that could certainly be included as part of the operation.
It's beautiful, like design and beautiful, like thinking. Barent, it's really amazing. How can we help support you with the work that you're doing? Like, give us a call to action. Like, tell us what to do. We'd love to
right now,
stay in touch.
Oh, thank you. Right now, it's certainly the Kickstarter, right? Like, we have launched this campaign called the BioCyclr, where our process, if you're familiar with the circular economy, it's got kind of like 4 principles, and we've built them into our logo, in fact, right? Like the yellow is for renewable energy. We need to run everything off of renewable energy. Then once we do that as designers, and I teach sustainable design at the new school, Parsons, and I teach my students that if we design everything to fit within a technical cycle and a biological cycle, then there is no waste, right? So if the technical cycles, metal, glass, plastic, this is the technical cycle, right? We've got single-use plastic into durable goods, but we wanted our first product to be the biological cycle. And so we are looking at creating the BioCyclr as our first product, so that we're touching both sides of the circular economy, right? Our process is this technical cycle, the BioCyclr is the biological cycle, the food, plants, trees. And so, but you can help us out by making the BioCyclr a reality, supporting our Kickstarter campaign by getting a BioCyclr food scrap collection bin. We think it's also a better bin, right? It fits in your door and fits biodegradable bags and holds your food scraps. So everything we make, we also want to make it better. Like, we're making a life preserver that we think is better because it supports the victim. So all of our designs are not just solar powered and not just recycled, but we want them all to be superior products. And so right now, that would be the best call to action, is to help us there. We're also looking for investors as we grow.
I was going to say, like, there's got to be funders
Absolutely.
that we know that we're watching, and people I'd love to introduce you to that should poke holes, spend their money, like invest in this.
I would love that.
The
I would love
idea of
that.
the
Yeah.
of the decentralized microfactories that can go anywhere in the world because of the solar power is so beautiful.
Awesome. Well, thank you, Sarah. Yeah, we are currently looking for investors right now. So yes, for people in that position, that would be another way to help. And then just follow along, join our newsletter, follow us on social. Celeste is behind the camera now, but she's been banging out all kinds of terrific updates on what we're doing. We've got time lapse. You saw it in part of the video earlier of this being installed. We've put the entire microfactory. There's a 3D model on there that you can rotate around. So we're trying to be very transparent about what we're doing, and you can follow along through all of that on our social channels.
Awesome. Well, I'll definitely make sure that we have like the links and the captions are in the threads and comments so y'all can find. I think you all might already be able to find those. And Barrett, you'll give us like a little 1 minute talk as well, right?
That's
For
absolutely, yeah.
Yeah, for TEDx Happily, which is coming up October 30th. It's going to be a 1 hour broadcast. Everyone, all the speakers that we've curated are doing really short talks so we can fill in as many of these beautiful, wonderful solutions for a carbon zero planet altogether. So I'm so looking forward to your talk, but I have just really, it's been so delightful for you to bring us to Governor's Island and show you the product and all of the process, Barent. And it's great to see you.
Good to see you. Yeah, when next time in New York, you'll have to come out and visit us, and
100%.
we can.
I definitely want to see that in person. Thanks so
Yeah,
much,
it's pretty
everyone.
awesome.
Have a great day. Bye.
Awesome.